Hey guys, welcome back to another practice questions on complex numbers. This question is taken from the 2018 Catholic Junior College Prelims Paper 1, question number 11. So if you are ready, let's jump right in. Now this is a very common question where you are given a root z equals to minus half to this cubic polynomial equation. So since this is a cubic equation, there are three roots which are denoted by z1, z2 and z3. Now we will try to use the technique of comparing coefficients to find these roots. So what we can do is to express this polynomial in its factors. So the first factor is z plus half multiplied by az squared plus bz plus c equals to 0, where a, b, c are elements of a real number. So by comparing the coefficients of z cubed itself, a is equals to 8. Similarly, by comparing the coefficients of z squared, b plus half a equals to 4 minus 4 square root 2. Now since a is equals to 8, b plus 4 equals to 4 minus 4 square root 2. We have substituted the value of 8 into the a, and b is equals to minus 4 square root 2. This is a very quick way to find the values of a, b and c. So similarly, by comparing coefficients of the constant terms, half multiplied by c is equals to 1 and c is equals to 2. Now there we have it. We have z plus half multiplied by 8z squared minus 4 square root 2z plus 2 equals to 0. Now if you're unsure what to do next, not to worry, we are going to break them down into two parts. In the first part, we are going to use the quadratic formula to find the values of z. So this will be z equals to minus b, which is minus 4 square root 2 plus minus square root b squared, which is minus 4 square root 2 square minus 4ac, which is 8 multiplied by 2 over 2a, which is 8 multiplied by 2, which is 16. Now simplifying, we will have 4 square root 2 plus minus square root minus 32 over 16. Let's try to simplify this third further. This will be equals to 4 square root 2 plus minus square root 16 square root 2 multiplied by square root minus 1. The square root minus 1 will be denoted by I. In the following step, we will have 4 square root 2 plus 4 square root 2i over 16. And simplifying, we will have square root 2 over 4 plus minus square root 2 over 4i. Now this is not the final answer because we want to express the roots in exact form of r e to the power of I theta. So what we can do is to express this Cartesian form into the exponential form. There are two ingredients that is required. The first will be the modulus of these roots. So for example, to find the modulus of square root 2 over 4 plus square root 2 over 4i, this will be equals to modulus square root 2 over 16 plus 2 over 16, and this will be equals to half. Now the modulus of square root 2 over 4 minus square root 2 over 4i is also equals to half. And the next ingredient we are finding will be the argument of square root 2 over 4 plus square root 2 over 4i. If you can illustrate this on an Argand diagram very quickly, this argument lies on the first quadrant, and tangent inverse square root 2 over square root 2 over 4, which is equals to tangent inverse 1 is equals to pi over 4. Similarly, the complex conjugate will be minus pi over 4. You realize in the question that the argument of z1 and z2, z3 are in ascending order. So what we can do is to allocate minus pi over 4, which is the smallest argument, to the z1. Alright, so therefore z1 is equals to half e to the power of I multiplied by minus pi over 4. z2 will be equals to half e to the power of I pi over 4, and z3 is equals to half e to the power of I pi, because z3 lies on the x-axis. It is a real number. And with this, we have answered to the requirements of the question. Now let's move on to part 2 of this question, where we are required to find the modulus and argument of Z4. Z4 is in the form of W square over Z1. And this is a very obvious hint or a clue that we must express W in the exponential form so that we can simplify to find Z4. So W square over Z1 is equals to, let's convert it straight away into exponential form for W. It will be equals to square root 2 e to the power of I pi over 24. You square this entire expression over Z1, which is half e to the power of I minus pi over 4. Now recall your property of indices. We are going to simplify the numerator and the denominator, and this will give us 2 multiplied by 2 e to the power of I 2 pi over 24 minus I minus pi over 4. Alright, and by factorizing out the I, we have 4 e to the power of I, open a bracket, pi over 12 plus pi over 4, close a bracket, and by simplifying we will have 4 e to the power of I pi over 3. Now always answer to the requirements of the question. This is not the final answer. We would like to find the modulus and argument. So very easily the modulus of this expression Z4 is 4 and the argument is pi over 3. If you want to brush up on your complex numbers techniques, I will recommend you to run through a playlist on the complex numbers so that you can get more experience in this topic. I'll see you in the next video. Thanks for watching.